Today I'm going to go over solving radical equations. This is our first day, and then tomorrow we'll do some more practice of this. So to solve a radical equation, you first of all isolate the radical on one side of the equation. Like in example 2, the radical is by itself. All the other problems, the radical is not by itself. So you'll have to do that first. Well, I'm sorry, 5 and 6, it's already isolated also. All right, so once you do that, then you're going to raise each side of the equation to the power of the index. So a square root will get raised to the second power to undo the radical. A cubed root will get raised to the third power to undo the radical. And a fourth power will get a fourth root will get raised to the fourth power. And then if you have your equations in exponent form, then just remember whatever your denominator is, that's the power you're going to raise it to eliminate the exponent fraction. All right, so in our first problem, we want to get the square root of x by itself. So we're just going to subtract 5 from both sides of our equation. And when we do that, we will get the equation square root of x equals 7. Now that we have our square root on one side of our equation, we're going to do like here that I just highlighted, and we're going to square both sides of our equation. So when we square both sides of the equation, we're going to get x equals 49. All right, the next one, the radical is already by itself, so we can go straight to eliminating it by raising both sides of our equation to the fourth power. The fourth root and the fourth power undo each other, so we would just have x equals 3 to the fourth power, which is 81. All right, in our next problem, we need to subtract 10 from both sides. To get our radical square root of a plus 7 by itself. So when we subtract 10 from both sides, we're going to get square root of a plus 7 equals 1. Then to get rid of our radical, we're going to raise each side of our equation to the second power. When we do that, the square root and the square will undo each other. So on the left, we will just have a plus 7, and on the right, 1 squared is 1. Then to solve for a, we would subtract 7 from both sides to get a equals negative 6. Number 4, to get the radical 10 minus x by itself, we're going to have to add 3 to both sides of the equation. If we add 3 to both sides of our equation, we will isolate the radical. We'll have square root of 10 minus x equals 1. Now that we have it isolated, our radical, we're going to undo it by squaring both sides. The square roots squared, they undo each other. So we would just have 10 minus x equals 1 squared is 1. Then we're going to subtract 10 from both sides to get negative 1x equals negative 9. And then either multiply both sides by negative 1 or divide both sides by negative 1 to get x equals 9. All right. Now we have a couple problems that are in exponent form. So you could either rewrite them in radical form, or you can just do like we have up here, that whatever the denominator is, you're going to raise each side of your equation to that same number. So for this one, it's 1/2 power. So if we raise both sides of the equation to the second power, then it would look like this. And we would get 4 squared is 16, and then 1/2 times 2 is 1. So that's just going to be c minus 12 to the first power, which is just c minus 12. And so then to solve, we would add 12 to both sides to get 28 equals c. Number 6, same thing. You could rewrite it as in cube root form, or you could just raise both sides of the equation to the third power. 1/3 times 3 is 1. So now on the left, we just have 7p minus 1 to the first power. So we don't need to write that. We can just write 7p minus 1. And then -4 to the third power is -64. Then to solve for p, just add 1 to both sides to get 7p equals -63. And divide both sides by 7 to get p equals -9. All right, number 7, we're back in radical form. So we want to get the radical 14 minus 2a by itself. We've got this -2 out front, and so to get rid of that, we're going to divide both sides by -2. 0 divided by -2 is just 0, so we get 0 equals square root of 14 minus 2a. Then to undo our radical, we're going to square both sides. And 0 squared is 0. And then the square root and the square undo each other. So we just have 14 minus 2a on the right. Then we want to solve for a, so I'm going to add 2a to both sides. 0 plus 2a is 2a. So 2a equals 14, and then this is 0. So then just divide both sides by 2 to get a equals 7. All right, this next problem has a couple things to get rid of. We want to isolate square root of 43 minus 3x. So that means we have to get rid of the -4, and we have to get rid of the 18. So just like if this was an x right here, if this was -4x plus 18 equals -2, you would get rid of the 18 first. So that's what we're going to do here. So we're going to subtract 18 from both sides of our equation. And we will get -4 times the square root of 43 minus 3x equals -20. So now we just have to eliminate this -4 here, and that's -4 times the square root of 43 minus 3x. So we're going to divide both sides of our equation by -4. So now we have isolated our radical. So we have square root of 43 minus 3x equals 5. Now we can eliminate our radical by raising both sides of our equation to the second power. Square and square root undo each other. So on the left we have 43 minus 3x. On the right we have 25. So then we want to solve for x, so we're going to subtract 43 from both sides. When we do that, we're going to get -18. So we have -3x equals -18. Divide both sides of our equation by -3 to get x equals 6. All right, now 9 and 10 are a little bit different because there's a radical on both sides. But if they're the same index, then then you can still do this. And they are on number 9, they're both square roots. Number 10, they're both fourth roots. Excuse me. So in number 9, we're going to raise both sides of our equation to the second power. The squaring and the square rooting undo each other. So we would just have on the left-hand side, we would have x minus 8, and on the right-hand side, 43 minus 2x. Then you want to get your variables on one side and your exponents on the other side. So I'm going to add 2x to both sides of my equation to get 3x minus 8 equals 43. Then we want to get our numbers on the other side since our variables are on the left. So add 8 to both sides to get 3x equals 51. And then if you divide both sides by 3, you will get that x equals 17. Last problem. So for this one, we're going to, it's the fourth power, so to undo our radicals, we're going to raise each side of our equation to the fourth power. The fourth root and the fourth power undo each other. So on the left, we will have 27 minus 2d. On the right, we would have d minus 3. We want to get our variables on one side and our numbers on the other. I like to have my variable coefficient positive, so I'm going to actually add 2d to both sides. And that will give me 27 equals 3d minus 3. Then, since I put my variables on the right side of my equation, I want to put my numbers on the left. So I'm going to add 3 to both sides of the equation to get 30 equals 3d. Then to get d, I'm just going to divide both sides by 3. We'll get d equals 10. Okay, so there's some examples of like some of the simple solving radical equations. Tomorrow we'll do some that are a little bit more involved. Okay, so hopefully this video helped. If you have any questions, just make sure to email me or ask me in class tomorrow. All right, have a good day, everybody.